All right, guys. So today, what the plan is we are going to go ahead and review some of the properties and some of those application problems that we've been working on. And then I'm going to ask you guys to take a formative. So the formative is on the Google Classroom, and it's going to work just the same as the formative that we would take in class, where I'm going to ask you to not use your notes so that we can give you guys some real feedback. Before you guys take the formative, I will have some extra practice if you guys feel like you want that. You don't have to do the extra practice that's on the classroom. As long as you watch the video, you will be all good. So what we're going to start with is I'm going to have you guys go here. So this is page 5 in your notes. So it's a page that we skipped from earlier, but we're going to come back to it. And it should say, in the table, correctly identify the figure at the top. So go ahead and find that. And what I want you guys to do is I want you guys to pause the video and go ahead and try these 4 questions. Try to identify the figure and figure out when was the first clue that you think the figure can be determined. So go ahead and pause the video, try all 4 of these, and then we will come back together and talk about it. All right, so we're going to start with number 1. So that first top left box says it is a closed figure with 4 straight sides. Okay, so what this tells us is if we have a closed figure with 4 straight sides, that just tells us we have a quadrilateral. We don't have just another polygon. We don't have any other shape. 4 straight sides and a closed figure is a quadrilateral. So number 2 says it has both long sides and short sides. So, okay, we have long sides and short sides. So what that tells me is that it's not going to be a rhombus. It's not going to be a square. Because if it was either one of those, we would have 2 sides that, or all 4 sides that would be the same. Number 3 says its 2 short sides have the same length. And number 4 says its 2 long sides have the same length. So what this tells me is that we're not going to have like a trapezoid, because a trapezoid, our legs don't have to be the same. Our bases don't have to be the same. So we could have a kite because we have short sides and long sides. Or it could be a parallelogram. All right, number 5 says some of its angles are not congruent. So what this says, some of its angles are not congruent. So really that means that not all 4 are congruent. So number 5, this one cancels out having it be a rectangle. Because if it was a rectangle, all 4 of our angles would be congruent. Number 6, 2 of its angles measure 140 degrees, and 7 says 2 of its angles measure 40 degrees. Okay, so what this one tells me is this one actually eliminates the fact that this might be a kite. And the reason that it does that is because in a kite, we would have only 1 pair of angles that were congruent. And in this case, we have 2 pairs of angles that are congruent. So really what that leaves, I know it's not a square, it's not a rhombus. I know it's not a trapezoid or a rectangle or a kite. So right here at number 7, and I don't have my coloring turned on. At number 7, I have eliminated most of my pieces. Number 8 and 9 say its 2 short sides are parallel and its 2 long sides are parallel. So if I have short sides being parallel to each other and long sides being parallel to each other, that also tells me that the sides have to be opposite of one another, because I couldn't have two adjacent sides or consecutive sides being parallel. And then number 10 says its diagonals bisect each other. So if we're thinking about all of the different quadrilaterals that this could be, the only one that this would fit into would be if it was a parallelogram. And when I'm looking at this, it was actually at number 7 that I could say for sure that I knew it was a parallelogram and not anything else. And it's okay if you don't realize it right at number 7. If it is number 8 and 9 that tells you that it's a parallelogram, that's absolutely true. Since we know that we have two pairs of parallel sides, that would also be a very good indicator that we have a parallelogram. Okay, so the second one, so I'm moving to the top right corner now, is it is a closed figure with 4 straight sides. So I do know that it is a quadrilateral, and I'm going to write that up here. Okay, so actually for this one, I'm going to go ahead and write down all of the shapes that I know. That it could be, just so that I have kind of a list that I can come back to and refer to. So quadrilateral, parallelogram, rectangle, rhombus, square, kite, trapezoid, or an isosceles trapezoid. Okay, so in this one, it is a closed figure with 4 straight sides. So I know for sure I have a quadrilateral. One of its angles measures 45 degrees. Number 3 says one of its angles measures 135 degrees. Number 4, another angle measures 45 degrees. And number 5 says another angle measures 135 degrees. So really, number 2 through number 5 tell me that there are 2 angles that measure 45 degrees, and there are 2 angles that measure 135 degrees. So what this tells me, what these 4, it tells me that I can't have a square and I can't have a rectangle, because in both of those, I would need 90-degree angles everywhere. The other one that it's going to tell me that I could at least be more specific than would be a kite. Because in a kite, we only know that one of the angles are congruent. So if we have anything more than that, we could be more specific. Number 6 says 2 of its sides are parallel. And number 7 says its other 2 sides are parallel. So now I have 2 sets of parallel sides. So that means I do have a parallelogram. And that also means that I can be more specific than a trapezoid or an isosceles trapezoid. So I could have a trapezoid, but I know that I could be more specific. And again, it might be an isosceles trapezoid, we don't know, but we for sure can be more specific. Number 8 says all of its sides have the same length. So if all of my sides have the same length, then I know I have a rhombus here. Because a rhombus actually just has our opposite sides are parallel and all of our sides have the same length. So this is where we hit that definition of a rhombus. And then just double checking, making sure that we are right in our answer. Number 9 says its diagonals bisect each other, and number 10 says its diagonals are perpendicular. Those are both properties of a rhombus. So we could say for sure this shape is a rhombus. And we knew that at step 8 when we had two sides are parallel, two other sides are parallel, and all of the sides have the same length. All right. We are going to jump down to that bottom left-hand corner. I'm going to switch colors so that I can keep looking at that list to the right with our different shapes. So this one starts with, it is a closed figure with 4 straight sides. So I know for sure I again do have a quadrilateral. It has, number 2 says it has sides of 2 different lengths. Okay, so if I have 2 different lengths for my sides, that doesn't really narrow it down anymore, but we just know that we have 2 different sides. Each of its short sides has a length of 2r. Each of its short sides has a length of 3r. So I actually think here on number 4, this one should say each of its long sides, not each of its short sides. So we're going to change that. Number 4 should read each of its long sides has length 3r. Its perimeter is 10r, which makes sense if we do 3r plus 3r plus 2r plus 2r. That would give us 10r. Its short sides are perpendicular to its long sides. Ooh, so this one does tell me a little bit more. If I'm perpendicular, I would have a rectangle, right? If I have two short sides and 2 long sides, which would make my perimeter 10r, and my short sides are perpendicular to my long sides, I'm going to kind of draw an image off to the side here. If I had my 3r sides perpendicular with my 2r sides, that tells me for sure that this would be, my setup would be a rectangle. Now let's see if we can be any more specific here. 7 opposite angles are congruent. Its long sides are parallel, and number 9, its short sides are parallel. So in this problem, we actually can say at number 6, we know that this is a rectangle. All right, and last but not least, we are going to look at the bottom right-hand side. Number 1, it is a closed figure with 4 straight sides. Again, quadrilateral, perfect. Some of its sides have the same length. Number 3 says some of its sides are parallel. Okay. Number 4, it has 4 pairs of angles that are supplementary. Okay, so it doesn't tell us if they're consecutive, if they're opposite. It just says that there's 4 pairs that are supplementary. Then it does say that it has 2 pairs of angles that are congruent. Okay, so let's kind of take a step back. Number 3 said some of its sides are parallel. So what that means, some of its sides means at least 1 pair. So that means we would have to have at least a trapezoid, maybe a parallelogram, but we don't know for sure. And we can say that, okay, it has 4 pairs of angles that are supplementary and 2 pairs of angles that are congruent. Number 6 says it has no right angles. Number 7, its opposite angles are not congruent. Number 8 says 2 of its opposite sides have the same length. So if we know we at least have a trapezoid where 2 of its opposite sides have the same length, and we know that opposite angles are not congruent, and we have 4 pairs of supplementary, 2 pairs of congruent. Okay, so that looks interesting. Number 9 says its diagonals have the same length. And number 10 says its parallel sides have different lengths. So now I want to take a look at number 8 and number 10 together. Number 8 says 2 of its opposite sides have the same length. And number 10 says its parallel sides have different lengths. So what that means is if I'm going to draw a picture off to the side, my 2 parallel sides, they have to be different. So that means the other 2 sides, those legs, would have to have the same length. They would have to be congruent. So looking at that, given number 10, I would know that this for sure is an isosceles trapezoid. Okay, so the next part, this is I think one of my favorite activities for this lesson, is we are going to determine the most specific type of quadrilateral given the diagonals. So this is going to be very similar to the activity that we have above, but we are only given things about the diagonals. So what parts are congruent? What are they perpendicular? What do we know? So I'm going to just call them like the top row. I'm going to go 1, 2, 3. Bottom row, I'm going to go 4, 5, 6. Okay. Just so that we are kind of all on the same page here. So 1, 2, 3, 4, 5, and 6. Okay. So on the top one, all I know about this one is that I have 2 diagonals and all 4 parts of the diagonals are congruent. So right now, what this tells me is that my diagonals have to bisect each other because both diagonals are split into 2 congruent parts. And since they're all 4 the same size, my diagonals have to be congruent. So what shape, or what is the most specific shape that has diagonals that bisect each other and diagonals that are congruent? I guess not the most specific. Which shape has both the diagonals congruent and bisecting each other? Well, if you guys look back at our images, the most specific that we can be would be if we had a rectangle for number 1. Because if I were to draw kind of what my shape would look like here, as long as those are bisected and they're all congruent, I could see here that this would be a rectangle. Okay, number 2. Right now, what I know is I know my diagonals do not bisect each other. So I'm going to write that over here. Oh, I thought I switched my color. Oh, I did. My diagonals do not bisect each other. But the other thing I know is since I have congruent sides, but they're not on the same piece, I do know that my diagonals are congruent. So what shape would I have diagonals that do not bisect each other, but the diagonals are congruent? So take a second and look back at our definitions. This would happen if I had an isosceles trapezoid. All right, number 3, let's take a look. All right, I have here, the first thing that I see is I see that my diagonals are perpendicular. I have that right angle in the middle. I also see that my diagonals bisect each other. And I also see that my diagonals are not congruent. So, what shape has diagonals that are perpendicular, diagonals that bisect each other, and diagonals that are not congruent? Well, the most specific that I could be here would be if, oh, hello, if I had a rhombus. All right. So number 4, let's take a look. Right now, what I see with number 4 is I see diagonals that bisect each other, and I see diagonals that are not congruent. So take a look back. What diagonals bisect each other but are not congruent to one another? I would see that would be a parallelogram. All right, let's take a look at number 5. Right now I have diagonals that are perpendicular to one another. I have one diagonal that is bisected. So what shape has perpendicular diagonals, but only one of the diagonals is bisected? So when I'm thinking about this one, there's only 3 shapes that have perpendicular diagonals. It's when I have a kite, a rhombus, and a square. Well, we said when we were looking at number 3, that was a rhombus, that the diagonals did bisect each other. So I know for sure that this isn't a rhombus. And if I'm thinking about it that way, remember our definition of a square said that it was a rectangle, a rhombus, and a parallelogram. So that means that this can't be a square either. So the only thing that this could be when we have diagonals perpendicular, but only one diagonal bisected, is a kite. All right, number 6, we are going to take a look And again, we have diagonals that are perpendicular, but this time we have diagonals that are bisected, and we have that our diagonals are congruent. So again, I want to take a look at number 3, number 5, and number 6. So we said that since we have perpendicular diagonals, it could be a kite, a rhombus, or a square. Since both diagonals are bisected, we know that it could be a rhombus. But the difference between number 3 and number 6 is in number 3, the diagonals were not congruent, and in number 6, our diagonals are congruent. So if we have diagonals that are congruent, we want to check first, is that a property of a square? And it is. So number 6 is also a square. All right. The next thing that I'm going to do is I'm going to use some of these properties to fill in all the numbered angles with the appropriate angle measures. And I'm actually going to do this in a different video, so you guys can go ahead and watch that video and watch me do this next one.